Today's lesson is on multiplication and division with scientific notation. A review of scientific notation from our lesson yesterday, we recall that scientific notation is a mathematical expression used to write very large and very small numbers in a simplified form. This form will always have one digit in front of a decimal point. That digit can never be a zero, and it will be multiplied by a power of 10. Here are three examples of proper form for scientific notation. Notice that you can have many digits after the decimal point. However, there is always only one digit in front of the decimal point, or you can have a single digit with no decimal, and that is still okay as long as this is a single digit in front of the decimal point. So these are correct form. These three examples are not proper notation, because if you see in the first example, there's a 0 in front of the decimal point. We can never have a 0 as the digit. Also, the next two examples have two digits that would be in front of decimal points. So these are also incorrect form. So these cannot be proper form. Proper form is a single digit in front of the decimal point, and it's multiplied by a base 10 with an exponent. There are three parts to an expression written in scientific notation. The first term is called the coefficient. This is the number that can only have one digit in front of the decimal point. The second term has a base of 10, always a base of 10, and an exponent. When we change scientific notation from improper form to proper form, we have to remember that we can move our decimal point to make it proper. However, when we move our decimal point, we're also changing the power on the exponent. In this case, we need to move our decimal point back one place. By moving it back one place, we took away one power of 10. So we need to add a power of 10 to our exponent. And our final answer would be 1.276 times 10 to the 8th. Because we moved our decimal point back, we add 1 to the exponent. Here's another example. In this case, our decimal point must be moved back two places. Since we moved our decimal point back two places, we add 2 to our exponent. And we get a final answer of 1.327 times 10 to the negative 3. When a term is smaller, when we make the term smaller by moving the decimal point back two places, we have to add that many places to the exponent on the base 10. Here's another example where we have a decimal times 10 to the third. In this case, we're going to be moving our decimal point forward one place. When we move our decimal point forward one place, we need to subtract 1 from our exponent. And so our answer becomes 7.82 times 10 to the second. When we make the first term larger by moving the decimal point forward one place, we have to subtract 1 from the exponent on the base 10. In this example, we're moving our decimal point forward 3 places. By moving it forward 3, we must subtract 3. And our answer is 4.9 times 10 to the 5th power. This example will show you how we multiply expressions with scientific notation. Remember that the commutative property allows us to rearrange the terms in a product. If we start by rearranging these terms, we can put the coefficient terms together, 7.8 times 4.7, and then put the product of the powers together, 10 to the 5th times 10 to the 3rd. We start by multiplying the coefficients and we get 34.31. Next we multiply the product of the powers and we get 10 to the 5th times 10 to the 3rd, or 10 to the 5 plus 3, 10 to the 8th. Now, to solve this, we must write the answer in proper form for scientific notation. Notice that we must move the decimal point back one place. Because we move it back one place, we add 1 to the exponent. And the final answer is 3.431 times 10 to the 9th power. When we move the decimal point back 1, we have to add 1 to the exponent. In example 2, we'll do the same thing. We'll start by rearranging the terms in the product. We'll start by putting the coefficients with the coefficients and the exponential terms together. We'll start first to multiply the coefficients. 9.8 times 8.6 is 84.26. Next, we're going to find the product of the powers by adding the exponents, and we get 10 to the negative ninth. Notice again that this is not in proper form, so we have to write the answer in proper form by moving the decimal point back one place. We add 1 to the exponent, and we get 8.426 times 10 to the negative 8. Now that we've looked at multiplying expressions with scientific notation, we can look at division of expressions with scientific notation. We remember that multiplication and division are related, and so we'll find that their steps for being solved are also related in solving scientific notation problems. To start with, we're going to divide the coefficients. 9.3 divided by 3.1 is 3. And next we're going to divide the base 10 numbers. We see that we find the quotient of powers. We take the numerator exponent minus the denominator exponent, and we write the answer in proper form. 3 times 10 to the 8th power. In example 2, we will use the same steps. We start by dividing the coefficients. We get 0.65, 1.3 divided by 2. Next, we're going to divide the base 10 numbers. Because they have the same base, we can subtract the exponents, numerator exponent minus denominator exponent, and we get 0.65 times 10 to the 4th power. Notice that our answer is not in proper form. The decimal needs to move forward one place, so we need to subtract 1 from the exponent. When we do that and write it in proper form, we get 6.5 times 10 to the 3rd power. In summary, the correct form of numbers written in scientific notation is the product of a factor that is greater than or equal to 1 and less than 10, and it's multiplied by a power of 10. Here's an example, 4.578 times 10 to the 3rd power, where the coefficient is 4.578. The base is 10 and the exponent is 3. When multiplying numbers in scientific notation, we start by multiplying the coefficients. Next, we find the product of the powers, add the exponents. If necessary, we adjust the decimal point to be in the correct form so that there is only one digit in front of the decimal point. When dividing numbers in scientific notation, we use similar rules. First, we divide the coefficients. Next, we find the quotient of the powers, the numerator exponent minus the denominator exponent. If necessary, we adjust the decimal point to be in the correct form. To move the decimal point forward on the answer, subtract from the exponent. To move the decimal point back on the final answer, add to the exponent. And that is all. Thank you for listening.